Nullable reference types in .NET 8. Explore the benefits of nullable reference types and how they enhance code safety. Introduction to nullable reference types in .NET 8. Nullable reference types is a new feature introduced in .NET 8 that enables developers to annotate their code to indicate whether a reference type can be null or not. In previous versions of .NET, all reference types were considered nullable by default. This new feature allows developers to express their intention and enforce stricter null checks, leading to more robust and safer code. Why nullable reference types are important for code safety. Nullable reference types bring significant benefits to code safety. By explicitly annotating whether a reference type is nullable or not, developers can eliminate the possibility of null reference exceptions, which are one of the most common runtime errors in software development. This helps catch potential bugs at compile time rather than waiting for them to occur at runtime. Some key reasons why nullable reference types are important for code safety include nullability enforcement. With nullable reference types, developers can enforce that a reference type should not be null by default. This helps in avoiding null reference exceptions and encourages defensive programming practices. Improved code readability. By using nullable reference types, code becomes more self-documenting as it explicitly states if a variable or parameter can be null or not. This helps other developers understand the codebase more easily and reduces the chances of introducing bugs due to incorrect assumptions. Better collaboration. Nullable reference types enhance collaboration among team members by providing clearer information about the nullability of objects and variables. This reduces confusion and makes it easier for developers to reason about the code and identify potential issues. Earlier bug detection. By enabling nullable reference types, bugs related to null references are caught during the development phase itself. This saves time and effort by eliminating the need for extensive testing or debugging sessions to identify and fix these issues. Difference between nullable reference types and nullable value types. While nullable reference types deal with the nullability of reference types, nullable value types handle the nullability of value types. In .NET 8, nullable reference types allow us to annotate our code to indicate whether a reference type can be null or not. On the other hand, nullable value types, introduced in an earlier version of .NET, allow us to specify whether a value type can have a null value or not. Below is a comparison between nullable reference types and nullable value types. Nullable reference types annotates the nullability of reference types. Nullable value types annotates the nullability of value types. Nullable reference types introduced in .NET 8. Nullable value types introduced in an earlier version of .NET. Nullable reference types prevents null reference exceptions. Nullable value types allows value types to have a null value. Nullable reference types leads to more robust and safer code. Nullable value types can result in runtime errors if not properly handled. Enabling nullable reference types in a .NET 8 project. To enable nullable reference types in a .NET 8 project, developers need to add the nullable context options element to their project file and set the nullable element to enable. This tells the compiler to enforce strict null checks for reference types. This can be done by adding the following code to the project file. Enable configuring nullable reference types in Visual Studio. Visual Studio provides developers with several options for configuring nullable reference types. To enable nullable reference types in a specific project, developers can go to the project properties, select the Build tab, and check the Enable Nullability Analysis checkbox. This will enable the nullability analysis for the project and enforce stricter null checks. Additionally, Visual Studio also provides a code analysis feature that can be used to further enhance the nullability analysis. Developers can go to the project properties, select the Code Analysis tab, and enable the Nullable Reference Types option. This will enable more advanced nullability checks and provide additional warnings and suggestions to help developers write safer code. In conclusion, enabling nullable reference types in a .NET 8 project is a simple process that can be done through editing the project file or configuring the project properties in Visual Studio. By enabling nullable reference types, developers can benefit from stricter null checks and catch potential null reference exceptions at compile time, leading to more robust and safer code. Benefits of nullable reference types. Enhanced code safety with nullable reference types. Enabling nullable reference types in a .NET 8 project provides several benefits. By enforcing strict null checks for reference types, developers can achieve enhanced code safety. This means that potential null reference exceptions can be caught at compile time, reducing the chance of runtime errors and improving the overall reliability of the code. With nullable reference types, developers are prompted to handle null values appropriately, leading to more resilient and robust software. Reducing null reference exceptions and potential bugs. Another advantage of enabling nullable reference types is the reduction in null reference exceptions and potential bugs. When reference types are nullable, developers are forced to consider the possibility of null values and handle them accordingly. This helps to eliminate null reference exceptions that can cause crashes or unexpected behavior in an application. By addressing these potential bugs early on, developers can create code that is more predictable and stable. By enabling nullable reference types in a .NET 8 project, developers can significantly improve code quality and reliability. With enhanced code safety, potential bugs can be detected earlier, leading to more stable applications. This feature, along with the ability to configure nullable reference types in Visual Studio, provides developers with powerful tools to write safer and more robust code. So, don't hesitate to leverage nullable reference types in your .NET 8 projects and enjoy the benefits they bring to your software development process. Working with nullable reference types. Using the null forgiving operator in nullable reference types. Enabling nullable reference types in a .NET 8 project provides several benefits, including enhanced code safety and reduced potential bugs. With nullable reference types, developers are prompted to handle null values appropriately, leading to more resilient and robust software. However, there may be cases where a developer knows that a reference type will never be null, even though the compiler cannot determine it. In such cases, the null forgiving operator, denoted by the postfix backquote, can be used to tell the compiler that a value will never be null. This helps to suppress unnecessary warnings and allows the developer to confidently proceed with the code. Working with nullable reference types in practice. When working with nullable reference types, developers should follow some best practices to effectively utilize this feature. Enable nullable reference types in the project settings. Review and update existing code to handle null values appropriately. This includes adding nullability annotations to variables and parameters. Use the null forgiving operator on variables that are known to never be null. Include nullability checks and handle null values in appropriate ways. Regularly compile and test the code to catch potential null reference exceptions and ensure code reliability. By following these best practices, developers can maximize the benefits of nullable reference types and create more stable and predictable software. In conclusion, enabling nullable reference types in a .NET 8 project offers several advantages, including enhanced code safety and reduced potential bugs. By utilizing nullable reference types effectively and following best practices, developers can improve the reliability and stability of their code. So, don't hesitate to leverage this powerful feature in your .NET 8 projects and enjoy the benefits it brings to your software development process. Interoperability with legacy code. Handling nullable reference types in legacy code. One of the challenges developers face when migrating to nullable reference types in a .NET 8 project is dealing with legacy code that was not designed with nullability in mind. In such cases, it is essential to update the code to handle null values appropriately and enable nullable reference types where possible. This may involve adding nullability annotations to variables and parameters, as well as using the null forgiving operator to indicate where values will never be null. By taking these steps, developers can ensure that their legacy code works seamlessly with nullable reference types and minimize the risk of null reference exceptions. Best practices for migrating to nullable reference types. When migrating to nullable reference types in a .NET 8 project, it is important to follow a set of best practices to ensure a smooth transition. Start by enabling nullable reference types in the project settings. Gradually update existing code to handle null values appropriately, adding nullability annotations and using the null forgiving operator where needed. Thoroughly test the code after each update to catch potential null reference exceptions and ensure the reliability of the application. Consider using tools and analyzers provided by the .NET ecosystem to assist with the migration process. Document the changes made to the codebase and communicate them to the development team to ensure everyone is aware of the new nullability rules. By following these best practices, developers can successfully migrate their .NET 8 projects to nullable reference types and leverage the benefits they offer, such as improved code safety and reduced potential bugs. In summary, when working with nullable reference types in a .NET 8 project, it is important to handle null values appropriately in legacy code and follow best practices for migration. By taking these steps, developers can ensure optimal interoperability with legacy code and maximize the benefits of nullable reference types in their software development process. Pitfalls and considerations. Challenges and common mistakes when using nullable reference types. When working with nullable reference types in a .NET 8 project, developers may encounter some challenges and make common mistakes that can impact the effectiveness of the feature. Some of these challenges include understanding and handling the flow of null values throughout the codebase, especially when interacting with legacy code that was not designed with nullability in mind. Ensuring consistent usage of nullability annotations and null forgiving operators across the entire project to avoid confusing and potentially incorrect code. Properly documenting and communicating the nullability rules to ensure all members of the development team are aware of and adhere to the guidelines. To address these challenges, developers should invest time in thoroughly understanding the concept of nullable reference types and how they affect their code. They can also leverage the tools and analyzers provided by the .NET ecosystem to detect and fix common mistakes. Performance considerations with nullable reference types. While nullable reference types bring significant benefits in terms of code safety, they can also introduce some performance considerations. When working with nullable reference types, developers should be aware of the following points. Adding nullability annotations and using the null forgiving operator can introduce some additional overhead, especially in performance-sensitive scenarios. Care should be taken when using nullability annotations in performance-critical sections of code, as they can impact execution time. Developers should consider the overall impact of nullable reference types on their application's performance and make informed decisions regarding their usage, especially in high-performance scenarios. By considering these performance considerations and making informed choices, developers can strike a balance between code safety and performance when working with nullable reference types in a .NET 8 project. In summary, developers should be aware of the challenges and common mistakes when using nullable reference types, as well as the performance considerations. By understanding and addressing these considerations, developers can effectively leverage nullable reference types to enhance code safety while maintaining optimal performance in their .NET 8 projects. Tools and resources. Helpful tools and resources for working with nullable reference types. When working with nullable reference types in a .NET 8 project, developers can benefit from using various tools and resources. These tools can help with understanding and implementing nullable reference types effectively. Some helpful tools and resources include nullable reference type analyzers. The .NET ecosystem provides analyzers that can help detect and identify common mistakes when working with nullable reference types. These analyzers can be integrated into the development environment to provide real-time feedback and suggestions for improving code quality. Code editors and IDEs. Modern code editors and integrated development environments, IDEs, often provide features and plugins that can enhance the experience of working with nullable reference types. These features can include automatic null checking, intelligent code completion, and visual indicators for nullable reference types. Community forums and discussions. Engaging in online communities and participating in discussions can be a valuable resource for developers using nullable reference types. These forums provide a platform for sharing experiences, asking questions, and learning from others who have already worked with nullable reference types. Conclusion. Final thoughts and future of nullable reference types in .NET. By utilizing these tools and resources, Developers can enhance the overall quality and safety of their code when working with nullable reference types in a .NET 8 project. The future of nullable reference types in .NET looks promising, with ongoing developments and improvements expected. As the adoption of nullable reference types increases, it is likely that more tools and resources will become available to further support developers in this area.